Hi guys, so now we're going to talk about using a table to solve energy conservation problems. We haven't learned about EPE yet, but we do know about GPE and KE, and we're getting real numbers for those right now. So we're going to use just GPE and KE, and we'll do EPE next week. So I'm going to skip this first part since we introduced this actually, either earlier this week or last week. Usually I introduce it here, but I introduced it early this year, so you don't need that. So basically what we're going to do, we're going to fill in the rest of this table, which is what we did yesterday. And then we're going to solve this problem down here using the table. So a lot of this stuff you probably already know. I just want to get this into your notes. You probably spent today practicing that on the station work. So anyway, the key here is if we have a table like this, we know that E total, this last column, this is all gonna be the same. And we know that GPE plus KE equals E total. So for column one, we already have enough information for E total. 100 plus 0 is going to be 100. And there we go. The next thing I do is I just fill the hundreds in. And I'm sure, wow, that's ugly. You guys know what to do from here. And you're already faster than me because you don't have to draw with your mouse and your trackpad on your Chromebook like I do. Whoa, so all of them have 100. So now I'm going to go through and fill in the KE. 75 plus what equals 100? Well, 25. And I'm not going to worry about sig figs in, wow, that's bad. That's really bad. Do we have an eraser? We do have an eraser. Okay. I'm not going to worry about sig figs because I'm having a hard enough time just drawing the actual numbers. You guys watch Khan Academy, you can't respond to me right now. But if you do, I am like so impressed by that guy because he draws awesome. So that's a 25. Then we would get 55 for this next one because 45 plus 55 equals 100. Woo. And then this last one, I'm just going to draw an arrow down here because I'm running out of space. The last one would be 22.5 plus, I'm going to say 77.5. Maybe I'll check that. I'm pretty sure that's what it is. Let's use our calculator. 22.5 plus 77.5. Yep, that's 100. Great. So we're all set with that. Okay, so then from there, who knows what the question's going to ask us, but at least we're set up for success. I'm going to come back here. All right, so now let's go down. We are going to, that's funny how that just keeps going. We're going to solve using this problem using this table. I'm going to erase this. Lucky for you guys, you can just go back if you don't have that written down, which is crazy if you don't have that written down, but you guys can always just rewind this and go see what I got. We're just going to erase that much. Sorry if that bothers you. So we're looking at here, we've got a 5-kilogram bowling ball. It's moving at 10 meters per second. We rolled it up a hill. What will be the speed when it has a height of 1.5? And we're going to use G equals 10 like we do. So this is a little bit messed up. I was trying to fit everything on the page. So over here it says label the types of energy on the diagram, which we always do. So we're going to use the ground is 0, a height of 0. So this one is only going to have KE. Whoa, that's a big K. KE. And we're just going to have to remember that that's V equals 10. And then number 2, because it's off the ground, it's GPE. And then we're going to assume it has KE. Mostly because it says what will be the ball's speed and there's an arrow. It's possible that we'll get that the GPE here is equal to the KE at the first point. And then we would know that there is no KE, so it stops right there for a split second, then it'll roll back down. Whoa. It'll roll back down the hill. But so there's no problem in assuming there's going to be KE, even if we're not completely sure that it's gonna roll. Okay, or that it's gonna that it still will have a speed. So anyway, then it says next thing, write down the givens. Listen, I'm not going to write down the givens right now. I'll write them down in here because it's going to be way easier for me to type. So that's where they're going, my friends. Okay, so anyway, So it says to calculate KE1, then fill in what you can for the tables. So for KE, what we're going to do is we're going to write down our givens. Our V1 is equal to 10.0 meters per second. And then our mass is equal to 5.00 kg. So there's my givens for that one. So, and I'll even just write down kg. And we're not using a full guide here. We're just kind of using, we're just following along the directions because it tells us to. So calculate KE1. So KE1 is KE equals 1/2 mv squared. So what we're going to do down here, so I'm just going to plug in my M is 5.00, and then my V is 10.0, and that is going to get squared. Okay, so then I'm going to go over here. I probably don't need this, right? Because half of 5 is 2.5. 10 squared is 100. 2.5 times 100 is going to be 250. Hopefully you understand where I came up with that. So hopefully mental math, there we go, 250 joules. Okay, so we're going to fill that in up here. It says fill in what you can. So 250, and it's going to be 250 dot. Oh, this is so small. 250 dot, because there's 3 sig figs in 5.00 and 3 sig figs in 10.0. So the GPE we already know is 0. So our E total, okay, which is our E total is going to be 250. So hopefully this, all right, this goes with this. Oh, this is not working. Whatever. I just can't write. I'm, like I said in the last video, I meant to do this on the iPad. So anyway, E total is also, this isn't something we would normally do, but this thick pen is driving me nuts. So E total and KE are both 250 for this guy. All right, great, super. So we're going to move on to the next part where it says calculate GPE2. No. Okay, great. And then fill in what you can for the table. So I'm going to write down my givens again. Hello. We've got mass, which is 5.00 kilograms. I'm going to write height down, which is 1.50 meters. Actually, I'm going to go back here and put that 250 dot in there so we have 3 sig figs. So over here, we're going to set this up. We're going to say that's 5.00 times 10 times 1.50. I'm going to fill in a G equals 10. Okay, so I'm going to do 50 times 1.5. I'll actually use the calculator for this today. 50 times 1.5. So 75. 75, and I'll put 0.0 joules. So that would go into GPE. So GPE1 is 75, and in the diagram, or in the table with this stupid marker, I'm just going to write 75. Alrighty, so we're going to go down to the last one. I'm going to move it up a little bit because we don't need to worry about it. All right, so use KE2 to solve for V2. So we know that E total, I'm just going to do it down here, screw that stupid thick marker. E total is equal to 250 dot joules. Okay, so we know that E2 is equal to GPE2 plus KE2. So we're just going to solve this real quick. So we're going to say 250 dot equals 75.0 plus KE2. And from there, we're going to say KE2 is equal to 250 minus 75, which we should get 175. Why is it not blue anymore? I don't know, guys. So 175 joules. I'm going to check that again because I'm feeling a little tired this morning. And I want to make sure that I'm correct. Yep, 175. So here we go. Last part of this. We're going to plug into KE. Well, maybe I'll even put it up there. Oh, we're going to stop in 27 seconds, it says. So maybe I won't. Okay, so I'm going to plug in. 175 is equal to half of the mass, which is, oh my God, 5 times V squared. Yep, we're out of time.